What's up, elasmites, and welcome back to the podcast that curls your hair and your mustache. Speaking of mustaches, boy do I, your host Sam McNeely, have a graceful and majestic episode for you today on manta rays, the large cousin of the stingray. But first, let's jib-jab. Thank you, loyal and returning listeners, and welcome all newcomers. Today's episode is obviously amazing, but our past episodes are also really fun and informative too. And thank you Patreon donors who literally keep this show afloat by giving at patreon.com/elasmospod. And if you're thinking about supporting me and my educational shenanigans, please check out that Patreon page to see what additional benefits you can receive by becoming an elasmite donor. Thanks also to those who rate and review this podcast. And remember, if you rate and review this podcast on whatever platform you're listening to it on, and send that rating and review to me at elasmospod@gmail.com, you'll be entered into a raffle to win a prize from our episode 1 guests. And who doesn't love a free prize? And if you share this podcast on social media, you'll get 2 extra entries into that drawing. So rate, review, share on social media, and email me at elasmospod@gmail.com. You can find the Elasmos Podcast on Instagram and Twitter at elasmospod, and our Facebook page and YouTube channel are both called the Elasmos Podcast, A Shark's Universe. Our website is elasmospod.com, where you can find all the links to all of these things, so go check that out. And lastly, don't forget to share your listeners' adventure stories with me to encourage ecotourism and embrace the world around us, because we all deserve to take a second look in the mirror and say, I shouldn't be standing in front of a mirror. I need to go outside. And you can do that by sharing your stories with me by emailing them to elasmospod@gmail.com. Alright everyone, now's the time you've all been waiting for. Prepare yourselves for this charismatic episode with the Media and Communications Coordinator of the Manta Trust. He's a world traveler from the UK, where he went to the University of Southampton. We go over a lot of his background, so I'll leave his intro short and sweet, but we really covered a lot more than I thought I could in an interview. We primarily focused in on the heart and soul of the Manta Trust charity organization, but we also chatted about whale sharks, pseudomedicine, the mind of a manta, or as I'm now calling it, manta mentality, brushing your teeth with fish, citizen science, underwater ultrasounds, and of course, without fail, we talked about Sir David Attenborough. Shark lovers, allow me to introduce to you the wonderful Simon Hilbourne. This is episode 8. Let's start out easy. What's your name and what pronouns do you go by?
Yeah, so my name's Simon Hilbourne and he or him.
Wonderful. And so where are you from and where are you currently located, just for our listeners out there?
I'm originally from the UK, but I was born and raised overseas, so I had a bit of an odd kind of upbringing. I am English, but yeah, most of my life has been spent overseas in different countries around the world. I am actually currently back in the UK now, so I'm currently based in Bristol in the UK, and all my work for the Manta Trust currently is remote online.
Oh, sweet. That sounds like a fun childhood. Were you just traveling a lot as a kid?
Yeah, both my parents were teachers at international schools, so we sort of moved around from country to country. So I spent a fair bit of time in the tropics in Thailand, and that's where I learned to scuba dive and kind of fall in love with the oceans and start to see that sort of stuff that ended up being my career, I guess.
I know we're bound to have crossover episodes eventually, but already? I mean, Liz from episode 2 lives in Thailand and works there. Come on, this is too weird. Is Thailand like the secret meetup place for marine scientists? I mean, I'll go. Anyone else down? Let's plan a trip. So what was it that first got you interested in science just in general?
I was always interested in sort of biology at school. Always fascinated with kind of how the body works and how life works and ecosystems and all that sort of stuff in biology class, which was super fascinating.
Mm-hmm.
And then, yeah, in terms of marine biology, I learned to dive at quite a young age when I was, I think, 11 or 12, did my first dives, and then
Oh my gosh.
dived with dive with my family quite regularly. They were sort of recreational divers as well, so it was nice, like little family holidays.
Oh, that's
And
so
yeah,
fun.
just kind of got more and more interested in the animals and stuff like that. And then whilst I was on my gap year in Australia working as a dive instructor, I kind of really realized that I was much more interested in the animals and the sort of science and the conservation side of things rather than the tourism side of teaching people to scuba dive.
Okay, just a few quick things I want to unpack here. What was it like learning to scuba dive at 10? I just learned how to scuba dive a year or two ago, and I mean, it was just surreal. I couldn't even imagine doing that, 14 years ago? Oh my gosh, I feel old. But that's just crazy. I don't even know if I could comprehend how amazing and how crazy of an experience that is at that age.
Yeah, I mean, it was great. I learned to dive in Thailand. The water there is beautiful and nice and warm.
Oh, so nice.
A lot of the reefs were maybe not as healthy as they probably should be. A lot of overfishing and stuff. So not a whole lot to see, but at least it was nice warm water, so it was quite easy.
Mm-hmm.
And yeah, I think being a kid, kind of that age, not much really scares you. So I think it was quite easy, and I just kind of felt pretty natural at it from the get-go. It wasn't you didn't have any of those sort of fears to overcome that maybe you grow into when you're a bit older and you start to think, should I really be trying to breathe underwater? Is that a clever thing to be doing?
Yeah, I guess that's true. That makes sense.
Yeah,
just gotta start them young, you know?
Exactly. Yeah.
And I guess that's kind of the same with sharks or elasmobranchs, is it's beneficial to teach kids when they're young that sharks are something to be respected and well understood, not feared to the point of we need to kill all of them, you know?
Yeah, before they've been brainwashed in the wrong sense and got the wrong ideas in their mind. Yeah.
Yeah, just brainwash them the other direction.
Exactly. Yeah.
And I'm curious because I took a gap year when I was in college, but what did you do on your gap year?
So I was working in Cairns in Australia on the Great Barrier Reef. I'd finished my dive masters, and then I was working as a sort of instructor.
Oh, that's sweet.
Training program. So I was getting experience working as a dive master, and then I got kind of a free instructor course out of it at the end.
Wow.
Definitely doesn't work out to be free, but it was a good way to do it, to gain experience and stuff like that.
For sure.
So yeah, diving on the Great Barrier Reef, working on liverboards and things like that. So it was really, really fascinating sort of experience. Got loads of time in the water, working on boats, like learning to tie out boats and rope work and things like that. At 18, it was kind of made me, I think, mature quite quickly because I was suddenly taking responsibility for families coming on holiday, and you kind of need to at least look like you know what you're doing.
Yeah, really. You're just thrown right into the fire right there.
Yeah.
And so you said you grew up in marine science, or at least in that realm. But how did your gap year experience working on the water and being in the water, how did that influence your path into more of the science communication side of things?
Yeah, so I think it probably was out in Australia. On one of the boats I was living on, I had a little sort of compact point and shoot camera, but a couple of the other guys on the boat working on the boat had big DSLR setups and taking amazing photos in between the guest dives. They'd just jump in and for a bit of a fun dive and come back with amazing photos. And that kind of got me hooked on underwater photography and underwater videography. And I really started to kind of enjoy that. And then whilst I was at university, I bought my own DSLR setup, secondhand, quite cheap.
Oh, nice.
Yeah, and started to learn to sort of play with that and learn to find my way around the camera and things like that. And yeah, it kind of just carried on from there. I was taking my own photos, and then it's like, oh, well, what do you do with these photos? And post them on social media, obviously. So I then made a Facebook page for my underwater photos, and then tried to I didn't want it just to be pretty pictures. I wanted it to have I was studying marine biology at university, so I wanted to have some sort of education or like content behind it. And yeah, it's kind of just gone from there. So yeah, I mean, my education qualifications are in marine biology. I did a master's in marine biology, but all the science communication side of things, that's just learned on the job really through practice kind of thing and self-taught.
Wow, that's really impressive. And yeah, even though your job as a dive instructor or a dive master is to take people out on the dives and kind of guide them around and stuff like that, you're part of your job is to teach them about what's around you and what they're seeing. So it's that on-job experience that really gets you into that science communication aspect of it. And then science communication becomes an integral part of the scientific process because, without science communication, what's the point of science,
Yeah, exactly. It's almost, I wouldn't say pointless, but it loses a lot of effect when you don't actually that knowledge and that research and stuff doesn't get disseminated anywhere past the sort of academia world. It kind of gets a bit wasted somewhat.
I agree. Yeah. So where'd you go to school for marine biology?
I went to university in Southampton here in the UK. So they've got sort of a big oceanography and marine biology department, which was great. But having grown up and lived in Thailand and Australia diving and stuff like that, to then move back to the UK and to do all of our field work on a boat in the Solent River, picking up like limpets and looking at rock pools and stuff, it wasn't really...
It's just a different flavor of marine biology.
Didn't have quite the same charm. But yeah, it was actually there that I had the opportunity to kind of pick the direction of my master's thesis, and I chose whale shark aggregations in La Paz in Mexico, in Baja California.
Oh my God.
So as soon as I kind of had an opportunity to pick somewhere nice and warm and tropic and do something fun, I jumped at it.
I would too. I don't think anyone would turn that down, especially for whale sharks. Come on. How'd you get to do that project? Like, for listeners out there that are interested in marine biology, and also for myself, because, I'm interested in grad school, but I don't really know what I want to do or how I can do the things that I do want to do, So how did you navigate that and get to choose to do kind of everyone's dream job?
Looking back on it now, I think I just basically reached out to lots of organizations and just kind of, just approach them saying, hey, I've got to do a master's project. I'd love to sort of work on any data you have. I would go for the sort of smaller grassroots organizations. They tend to have backlog of data and don't really have the time or hours to process it and to use it and stuff like that. So there's a lot of people out there collecting data, and then they just kind of sit on it because that's kind of the fun bit. And then you got the really boring bit of sitting down and writing the papers, but there's still more data to be collected. So it's just this endless cycle of collecting data, but not actually producing anything from it. So reach out to different organizations. I think I must have contacted a fair few, couple of dozen, until, the whale shark project in La Paz with Denny Ramirez. She had a bunch of data, and sort of offered to let me use it for my master's project.
So it was through your university at Southampton, but you were working in collaboration with this side organization?
Yeah. So it was at Southampton. It was just my master's thesis within the degree program. And then Denny was kind of a field supervisor out in Mexico.
Okay, gotcha. So Danny Ramirez was kind of your on-site supervisor for your research in La Paz.
Yeah, exactly. Yeah.
And so what exactly did you do for your master's research with whale sharks?
It was a fair time back now, but it was looking at basically the seasonality of whale sharks in the Bay of La Paz in Mexico, trying to figure out kind of what's driving their seasonality and why they rock up when they were. I kind of got part way to figuring it out for my thesis, and it was kind of linked with sea surface temperatures and El Niños and that sort of thing. So,
cool.
That was affecting whether or not it would be a big year or a bad year, small year kind of for aggregations, whether the season would be delayed or early or how long it would be and things like that. But there were so many more aspects to kind of really look into. And obviously whale sharks are migratory animals. So
yeah, they're pretty big.
I think to expand the project, I'd need to start looking at other areas. Okay, so not just what's happening in this bay, but what's happening in the wider Baja Peninsula region, out into the Pacific Ocean as well. Like there's probably larger scale oceanographic drivers which are having a part to play. But yeah, in my sort of thesis, I didn't have time to explore all of those different avenues.
Yeah, I know. Masters are kind of limited, at least in time. So you got to squeeze in what you can. And 2 years sounds like a long time, but for research, that's really nothing. It's funny. I've heard some of my mentors say a master's is like a sprint and a PhD is like a marathon. So maybe if you do a PhD, this could be your project.
Yeah, potentially.
Simon doesn't sound that enthused. So I call dibs. I called it. Sorry, better luck next time, suckers. It seems like for these larger animals, I mean, the larger the animal, it almost seems like the more distance it travels, and that may not be true in all cases, but I mean, as much as these whale sharks are migrating around, then you have to take into consideration so many other factors, because then they're moving across ocean basins, and there's just so many variables there. So then I would imagine it would make it just that much more difficult to research these awesomely ginormous sharks.
Yeah, absolutely. I mean, one of the big things is, finding out what the drivers are that attract something to an area. But even once you've figured that out and it's like, okay, well, this is the perfect conditions, like they should be here, often they're not. And that's maybe not because it's not perfect conditions where you are. Maybe there's just slightly better conditions somewhere close by, and that's where they've ended up going. So you can't really look at like this finite like location of, but it's now is the bad like period. It's not good conditions or whatever. They're not going to be here, or this is what's going to drive it, and they're going to end up. There's so many different variables and different aspects, and these systems are very fluid and they move. So,
oh my gosh.
Yeah, lots of things to keep in mind. Makes it incredibly difficult.
Yeah, really. That just sounds like a headache and a half. I mean, it's like whale watching. You never know when you're going to see them, and they know the best spots. But still, sometimes you don't even see a whale, or a dolphin for that matter. But man, as much as we want the world around us just to be static and remain the same and easy to interpret, Mother Nature just says, screw that.
Yeah. Yeah, biology doesn't really play to the rule books, does it?
No, it really doesn't. And so what specifically brought you to elasmobranchs? How did they seem to spark your interest over every other marine animal?
Whilst in Australia, we did a fair bit of shark diving, and there were quite a lot of sharks around. And I did think that I wanted to do sharks, basically, work on sharks, and I guess the bigger the better, and somewhere warm.
Yeah,
so yeah, I kind of ended up with whale sharks, and you can't really get any bigger, and nice warm water. So I thought I'd lucked out, kind of thing. And yeah, just fascinating, especially with whale sharks. They're such big animals, yet we know so little about them. It just kind of blew my mind that there was this massive gap in data about whale sharks. And I mean, with my thesis, barely even plugged a tiny hole of that like gap of data. There are still so many questions. And I think that's just what really, really fascinates me and draws me to them. And I love being in the water with them. So I know any sort of field time that I get, I'm absolutely going to love.
And that's just wild that we know so little about them. I mean, usually we think about the really small animals or organisms, especially in the ocean. It seems like the smaller the animal, the more difficult it would be to learn about it and to understand it. But for the whale shark, I mean, I don't know. That just seems so weird that we don't know that much about it when it's literally 40 feet long. It's literally a school bus in the ocean. And also, swimming with a whale shark. That's gotta be just breathtaking, to say the least.
Yeah, well, so the period that I was going in the summer, they weren't actually supposed to be in the bay.
Oh, no.
And then it turned out that the year I went, the sort of season just carried on longer, and they ended up still being there whilst I was there. And it was all a bit odd. So when I first approached the organization, they were kind of like, well, yeah, you can come, but chances are you're not actually going to see any whale sharks. Like, you can use the data and things like that. I was a bit bummed, but it turned out that they sort of hung around the whole time, and I got lots of great time in the water with them as well. So I was quite lucky.
Oh man, that is so lucky. It's like they knew you were coming and they just said, hey, come on, let's stick around a little longer for Simon.
Yeah, very, very kind of them.
God, that's so cool. I want to do that someday so freaking bad. And alright, so you work for the Manta Trust.
Mm-hmm.
What exactly is the Manta Trust, and what does it do?
Yeah, so the Manta Trust is a UK and a US registered charity or non-profit organization. And our focus is mantas and devil rays, but also their associated habitats and where they live and the sort of environments that they live in, and researching them. And then also a huge aspect of conservation, because the state of populations around the world of mantas and devil rays is not very good. So it would be probably wouldn't be doing our part if we were just researching them and not having any conservation value behind it as well. But yeah, the charity was set up in the Maldives. It started there in, I think, about 2005 as the Maldivian Manta Project.
Oh.
And then that sort of ran for 5 or 6 years. And then Dr. Guy Stevens, the CEO and co-founder of the charity, realized that sort of mantas don't just need research and protection in the Maldives. There needs to be sort of wider research and collaborative work going on.
Right.
So he set up the Manta Trust with, I think, 4 or 5 different affiliate projects around the world into this sort of umbrella organization, this umbrella group that were all working towards the same sort of common goals. And over the years, more and more affiliate projects have joined from different places all around the world. And I think we now have about 25 different affiliates all around the world.
Oh, that's amazing.
So a huge network of scientists, researchers, fisheries people, policy makers, filmmakers, all sorts of different stuff working on different projects all around the world. But yeah, it's kind of just a collaborative network of all these groups working towards a similar goal.
Holy cow, I didn't know it was that vast and expansive.
Yeah, it's a really big network, but the actual core team of the Manta Trust, there's only 7 of us. So
no way, really?
Yeah, so really small sort of core team. But then, yeah, all of these affiliate projects around the world, they all work to different capacities of what they're able to do as well. Some of them have their own sort of NGOs or charities,
awesome,
which do a lot of work. And like one aspect is mantas, and we sort of collaborate on that. And they've got big teams and things like that. Others are sort of a one-man team who's a dive instructor and just kind of wants to collect a bit of extra data on the mantas and kind of does it part-time in the background. So it does vary hugely, but yeah, all kind of got the same common goals. And we help them with getting funding and grant applications and things like that, but also with advice and specialisms and stuff like that. And then also promoting the work that they do at the end and sort of sharing that and getting that out to a bigger audience.
Wow, y'all do so much more than I thought. And that's really cool. It's like a two-way street. You help them out and they help you out.
Yeah, exactly. I mean, it's part of the package of being part of this affiliate network. Like we'll help them where we can. We're sort of bigger, more recognized, established organization. So part of this network is that we help these smaller organizations around the world.
Man, that's awesome. So how did you get involved with this organization, the Manta Trust?
So after working a little bit with whale sharks in Mexico and then in the Philippines, I joined the Manta Trust, or the Maldivian Manta Project, as a volunteer in the Maldives. So I spent 3 months working as a volunteer on the sort of internship program that we run.
Oh, cool.
And then, yeah, shortly after leaving that, a position opened full time doing the research stuff in the Maldives. So I then got asked to come back.
Oh man, I love when that happens.
Yeah, I took that position. I'd have been silly not to. So that was a full-time paid position out in the Maldives doing all the research kind of side of things, which was great. And then slowly, sort of transferred from that with just the Maldives project into the media and comms manager for the wider Manta Trust, the whole sort of network in the last couple of years.
I don't know why it just now occurred to me, but I don't know where the Maldives are. So I just looked it up, and the Maldives is a series of islands a few hundred miles south of India, and it teeters right near the equator. So that's going to be some warm water for some diving and to see those beautiful manta rays. Yeah, I'm pretty jealous. So your focus right now for the Manta Trust is specifically on media and communication.
Yeah, exactly. Yeah, hence why I don't have to be in the water anymore. I can be just desk-based. Which is not as fun, but it's part of the job, I guess.
Yeah, I know. Unfortunately, that's just part of it. But does that mean you're able to work remotely most of the time, and then you can go somewhere tropical and get your fix on diving in warm water?
Yeah. So our whole team is all working from home, sort of anyway, regardless of pandemic or not. So yeah, we have that flexibility, and I do get the opportunity to go out and visit some of these projects every now and then, help them out with their side of things, but I can also still do my day-to-day tasks as long as there's kind of internet and we can get connected.
It sounds like that must have been a pretty easy transition into COVID times when everyone's working remotely. I mean, you're already there.
Yeah, exactly.
And that's gotta make work when you're out at those different places, just making sure things are running smoothly. It's gotta make work feel so much less like work.
Yeah.
I mean, you're practically in paradise.
Yeah, I mean, it's these trips are work, but they're great fun. I love the work that I do, so it doesn't really feel like work. And yeah, having these trips every now and then, yeah, definitely makes it more enjoyable.
I definitely get that. The job I'm working right now, it's either at a desk cold calling people, or I'm out in the field gutting some fish and taking samples. And I know that doesn't sound like everyone's dream job, but being out in the field is 1,000 times better to me than sitting behind a desk cold calling fishermen. Let me tell you, it's a lot better. So earlier you said that the Manta Trust is based around a multi-dimensional approach, focusing in on research, education, and collaboration. Could you explain how this multi-dimensional approach makes the Manta Trust a successful charity and organization in general?
Yeah, I don't think you can really do any of the research, education, or collaboration. I don't think they're mutually exclusive. So you can't successfully do research and to the best of its ability without some aspect of collaboration and working with other groups and other researchers or universities or whoever it might be. And similarly with education, like you can't effectively educate people if you haven't done the research, and it's all sort of like intertwined and reliant on one another. So yeah, that's kind of the three aspects that we strive for conservation of these mobulid species, is through the sort of scientific research, but then also using that in our education programs, whether that's educating school kids, whether that's educating the general public through webinars or presentations, or whether it's educating policymakers and using that scientific knowledge at a policy level to affect change in whether it's conservation management through international bodies like IUCN or CMS or something like that, or whether it's at a national level where a country is deciding whether or not to give protective status to mantas or devil rays. So yeah, it's all kind of intertwined, but all equally important.
Yeah, I think you said it best. One without the other really just doesn't work as well.
Yeah, I mean, it's possible. It's just not as effective, and it's not getting the best out of it, really.
Absolutely. Each just strengthens the other. Now, so I'm not too familiar with my rays, especially when it comes to like manta rays and even devil rays. I didn't even really know were a thing until you said it. But manta rays and devil rays are part of this group called mobulids. Is that right?
Yeah. So they're all mobulids.
It's pronounced mobulids. Damn it, I knew I'd embarrass myself today.
The mantas and the devil rays, they all fall into the same sort of classification these days.
Okay, gotcha. Now, so what are some specific ways that the Manta Trust is working to conserve mobulids?
Yeah, so we've got a wide range of research activities happening around the world. A lot of them are focused on data collection about these species. Similar to the whale shark, we just don't really know much about them. In the case of manta rays, the two species of mantas, oceanic and reef, we're starting to know a fair bit about their life history, where populations are, how many there are, how far they move, how long they live, how often they have babies, all this sort of stuff, which until recently wasn't known or wasn't very well understood. So we're starting to really get some way to having a good understanding of that. But
Awesome.
For the devil rays, their smaller cousins, for a lot of the species, we still have no idea about this sort of stuff. So
Really?
huge gaps in research or knowledge. So yeah, a lot of our affiliate projects are out in the field, sort of collecting data, looking for these mantas, running photo ID programs, collecting citizen science, deploying tags, collecting genetic samples, looking at environmental variables, all the sort of field work activities around alive animals. And then we also have a number of affiliate projects who work closely with the fisheries industries.
Oh, interesting.
So in Peru, in Indonesia, in Sri Lanka, there has and there still is quite large scale fisheries for mantas and devil rays. So those teams there, they're visiting the fish markets, they're quantifying how many of these rays and also sharks are being landed. Is it seasonal? Where are the fishermen getting them from? What sort of nets or fishing equipment are the fishermen using, to try and understand more about that sort of threat level of okay, how are mantas and fisheries interacting, and where is it happening, and how can we best reduce the negative interactions between the two?
Oh my god, y'all do a lot. So I know the big problem with sharks is shark finning. Their fins are cut off and it's really hurting their populations, but how does that work with mobulids? I mean, sharks are kind of like a body and then a fin, but it seems like manta rays are all fin. It's just one big fin.
It's kind of similar. So mantas and devil rays, they're often caught, or sometimes it's targeted catch, sometimes it's just as bycatch. But a lot of the economic value in mantas and devil rays comes from their gill plates.
So when you look at the gills of a shark or really any fish, you are seeing the outside and that's just the skin. But what you aren't seeing is on the inside, and those are the gill plates and the gill rakers. So gill plates look a lot like ferns, and they're just used to absorb oxygen from the water that moves through their mouths, and they also pump out carbon dioxide. So they're basically the lungs, but for fish. And they also absorb minerals from the water, and they balance out ions in the body to keep the body at an appropriate pH. They're actually really cool looking, and they do a lot. So it's kind of crazy how much a mouth fern can do for these large pancake sharks.
So each manta has 5 pairs of gill plates, and those are dried out very similar to shark fins, exported to mostly southern China, Guangzhou, Hong Kong, areas like that, where they're used as a pseudo remedy for things like asthma, cancer, chickenpox.
Really?
There's a whole raft of different ailments that supposedly gill plates can cure. No scientific value for any of it.
Oh my god.
And in the same sort of way that shark fins is very wasteful, and it's just the fins that are used and the meat is often discarded or not very valuable, it's the same with the mantas. Some regions do eat manta meat, but it's very rarely a delicacy. It's normally sold very cheaply. So it's hugely wasteful, and these animals, they're just not, their life history traits don't lend themselves to being an animal that can be in any way, shape or form sustainably harvested or caught or killed. So any kind of destruction of the population can have huge impacts for the wider species, really.
That seems to be a recurring theme with elasmobranchs. Now, so to take it back just a little bit, I've always lumped manta rays into the same category, I guess, as stingrays and skates, but it sounds like manta rays and devil rays are within this mobulid group that is unique and different from stingrays and skates. What's that difference?
Yeah, so obviously there's lots of different types of stingrays and different species. Mobulids are most closely related to eagle rays and cow nose rays. So those two have kind of the diamond-shaped body as well, which we get with mantas and devil rays. A lot of the other stingrays have circular sort of disc of the body. Most of the rest of the ray species are benthic, so they're feeding and foraging in the sand, looking for mollusks and crustaceans and things like that to eat. Whereas mantas and devil rays, they've evolved to have a more pelagic lifestyle. So they're living and feeding almost completely in the water column. So they very rarely rest on the sand or live on the coral, in the coral reef. They're out in the open ocean or in the water column, filter feeding on plankton. They've also evolved these cephalic fins, so head fins, I guess, which they can roll up. And that's where the devil rays get their name, devil rays, because it's these two sort of horn protrusions on their head, but it's actually these cephalic fins that unfurl.
Oh, that's what those things are? I never knew what those things were called. And so what's their purpose? What are they used for?
So with the manta rays, they unfurl them when they're feeding, and it acts as basically a funnel to push larger amounts of water into their mouth so that they can more efficiently feed. So it's basically, a filter, and then when they're cruising or traveling, they'll roll those cephalic fins up into more sort of horn projections.
I had no idea.
And another difference is none of the mobulids have, one or two they don't have stingers on their tail. So where stingrays, as the name suggests, has a stinger, manta rays don't have a stinging barb. So they're kind of completely harmless in that sense, but another slight difference between them.
Gotcha. I always thought a manta ray looked too majestic to want to sting me. I'm not trying to badmouth stingrays here, but manta rays just seem too innocent. Now, so what role do the mobulids play in the grand theater of the ecosystem?
Yes, this is something that we're still researching and looking into, but one of our affiliate projects in the Seychelles published a paper quite recently about this, and one of the key things that they do is basically nutrient cycling. They fill this unique role in the ecosystem where they're feeding on plankton in certain areas of the reef, but then returning to shallow reef areas to get cleaned, and they end up excreting. And they're basically taking nutrients in the form of food from one area of the reef, whether it's out in the channels of the reef or down in the deeper depths, consuming that plankton, bringing it up and basically pooing it out.
Whoa, man, you just ran through a big pile of dog shit.
It happens
What, shit?
sometimes.
And it's that nutrient cycling up into the shallow reefs, which is really important. And they found that no other species on the reef was really filling that ecological niche, which is quite important.
Oh, that's really interesting. That seems to be like an ecological role that I don't normally think about. And so you said that devil rays are kind of like the smaller cousins of manta rays. How big do they get?
Yeah, so the reef mantas, they grow up to about 3.5 meters in wingspan. So that's 11, 12 feet across, I think.
Jesus.
And then the oceanic mantas, they get up to 7 meters in wingspan. So that's 20 feet-ish.
Holy crap, that's giant. Oh my gosh.
That is
freaking enormous.
That is the highest end of the spectrum. I mean, that's like saying that humans grow to like 2.2 meters.
Translation? Over 7 feet.
Or something like, yes, very few do, but it is possible kind of thing. Most reef manta rays are around 3.5 meters in wingspan, and most oceanics are around 5.5, 6 meters in wingspan. So still huge, like size of a car, if not a minibus kind of thing.
Yeah, no kidding.
Weighing a couple of tons as well. So absolutely huge. The mobulid species, a few of them only grow up to about a meter or even less than a meter. So a reef manta is born at 1.2 meters. So even a newborn reef manta ray is bigger than what some mobulid species will attain in their lifetime.
Ouch. Those poor mama mantas.
Yeah, over 1 meter in wingspan at birth. The wings are sort of folded over on their back into kind of like a manta spring roll or a manta burrito kind of thing.
Well, now I'm hungry. And are all of these species migratory, or does it just kind of depend?
Yeah, again, this is the sort of thing that we're only starting to delve into.
Of course.
With reef mantas, they are migratory. They definitely move different areas in different parts of the world. Some of the mantas follow specific like migratory patterns, which we can see. So in the Maldives, they follow the monsoon season. So
interesting.
They'll swim from east to west coast of the atolls and back and forwards every 6 months. And we can clearly see this kind of migratory path. Other populations around the world, it's not as clear. They kind of follow the food source, but it depends on where that's going. With oceanic manta rays, the common thinking was that they were like ocean crossing animals, and they would swim from like one side of the Pacific all the way to the other, or like right across the Indian Ocean from Mozambique to Ninglu in Western Australia or something like that. But the thinking is really starting to change with that. The more we do satellite tagging of these individuals, and a satellite tag will only give you data for 6 or 9 months, like probably 6 months maximum, really. But it's starting to show that they're really not. They're kind of like hanging out in these specific areas for long periods of time. Maybe they make these like big ocean crossings once in a while, or maybe it's a generational thing. So like juveniles won't. And then as soon as they hit sort of adolescence or adulthood and they become sexually mature, suddenly they make a big migration to a new area, something like that. We're not sure, but they definitely don't seem to be moving quite as much as we once thought.
Maybe this is their teenage rebellion. Somebody's gotta test this, because that'd be a great name for a scientific paper.
And then with the smaller mobulid species, a lot of them live in open ocean, so we don't really see them on the coral reef. And that makes them incredibly hard to research and to kind of find. So for a lot of those mobulid species, we literally have very little idea. We know where they are and like where they've been seen, but we don't know much about how far individuals travel or when they travel or why they travel anywhere.
That kind of shocks me. I mean, it's like the whale shark. It's so big, and you would think we'd be able to have so much data on it because of its size and kind of like its noticeability, I guess. Maybe that's not the word. But like how unique and distinct it is that we'd be able to collect so much data on it, but we just don't have it because of its movement patterns.
Yeah, for sure. And I mean, a lot of these open ocean pelagic species are even harder, like reef mantas and for some part oceanic mantas. They visit coastal areas where people are scuba diving and stuff. So it's kind of easy to research. But if you imagine going out into the middle of the ocean and just kind of looking for mobulids or devil rays, you probably wouldn't stand much chance because you can only see the very surface of the water. And these animals can dive a couple of 100 meters. So they never have to come. They don't have to come to the surface to breathe. They're fish, so they're not sort of air-breathing animals. They breathe underwater. And so it's not like a whale or a dolphin where you can just kind of wait for them to come to the surface and you get lots of sightings. Yeah, if they're 50, 60, 70 meters underwater, you're never going to see them from a boat, even if you're in the water snorkeling or anything like that.
Yeah, and I want to ask you all these questions, but I know there's so little data out there for these species, but it's so interesting. And so do we know what their depth range is, I guess? Like how far beneath the surface they usually swim? I know there's a lot of different species out there, so it may vary a lot depending on that too.
Yeah, what we tend to see is that they spend like a good chunk of their time in the shallow surface waters, top 15, 20 meters or whatever, maybe even up into the top 1 or 5 meters. And that might be something to do with thermoregulation to warm up, basically in the warmer water.
Ah, okay.
But then we see a lot of parabolic diving, so they dive off deep into deep water, basically looking for deep water plankton layers, and then they'll kind of yo-yo up and down through those layers, presumably feeding, and then they'll come back up to the surface, probably to warm up, and then we'll see this sort of vertical migration, repeated dives.
Vertical migration in water is so cool, y'all. And it occurs in a surprisingly wide range of animals, too. All the way from manta rays to whales to sharks and even to my beloved copepods. And so a fun fact about the copepods that I got to work on in Maine, they make daily vertical migrations between the surface and about 100 meters at depth. And that's an animal whose length is literally the thickness of your fingernail. It's 2 millimeters in length. It's insane. And the crazy thing about vertical migration is the amount of variables that come into play. And the big one is pressure, especially underwater. So the pressure at sea level is almost 15 pounds per square inch. So that's like if you had an adult cat sitting on every square inch of your body. But every 10 meters or about 33 feet you go underwater, the pressure increases about 15 more pounds per square inch. So at 100 meters depth or 333 feet, you essentially have a St. Bernard sitting on every square inch of your body. And so what's really amazing about all these animals that are able to go up and down in the water column is that they're able to adjust to those huge differences in pressure. And so that's been one big area of interest for marine animals, but especially in marine mammals. So they have to account for lung compression, which is a whole thing on its own. But I don't have to explain it because this is a podcast about sharks and not whales. Whoa! Just kidding. It's really cool, and maybe someday we'll get into it. But let's get back to Simon before I derail even more.
But yeah, like you said, I mean, it's different for each species, it's different for populations. Then it even comes down to difference between seasons. When like that deep water plankton layer is higher in the water column, they're diving less. When there's good productivity in shallow waters, they'll just spend more time up in there. It's hugely dependent on different variables, but
right.
Yeah.
Right. Yeah, it's a very specific question for a broad group of animals. Yeah. And even though they seem like a pretty compact group of animals, like they're a certain type of ray, it's still a lot of species that just have so many different factors influencing them.
Yeah, for sure. But there's lots of really interesting research from these tagging studies about the sort of vertical migrations and how much time they're spending at different depths. And you can look at like what types of food they've been eating from stable isotope analysis and gut content analysis and things like that. So yeah, different species have different diet preferences, and then you can look at where that diet would have come from, and that's only sort of mesophotic zooplankton or that sort of thing. So it really starts to answer some questions, but also open up a lot of other questions.
That's the give and take with science. It's great because you never run out of questions because there's always more to know,
Yeah.
but then you never get to know everything. But I guess welcome to being a human. So, alright, so one thing my listeners probably know about me is that I'm incredibly enthralled with behavioral ecology and just that entire science. But more specifically, I'm really interested in social behaviors of different animals. So I grew up with the perspective that fish, really just all types of fish, were basically these brain-dead animals that were just moving in water just wherever the water takes them, and they don't have anything going on upstairs. It's just a bunch of rocks, you know. But in the past few years, I've really been opened up to the perspective that these animals have so much more going on behind the scenes, and I mean up inside their head, than we previously thought. I see a lot of pictures of these manta rays in packs or in groupings. So is this just a coincidence? Like, are they in a feeding ground, or are they social animals and they travel in kind of little herds or family groups or anything? I mean, maybe also the pictures of the groups of mantas are going to get more likes on Instagram than just one animal. So maybe it's just better for social media. But at some point, they've got to be gathering, right?
Yeah, possibly just what's good for social media, especially the mantas. They tend to be considered to be solitary animals. So they do live most of their life by themselves. There are species of mobula that definitely like aggregate in huge schools, like the Munkiana, the monk's devil ray. Off the coast of Baja, you get these huge aggregations of the little mobulids that jump out the water and stuff like that as well.
Oh, cool.
Whenever if there's a population of manta rays and there's a good amount of food availability, you will often get manta rays coming together to feed. And sometimes that is almost cooperative. So you get this sort of chain feeding where one manta is swimming and then there's a couple of mantas behind that are all sort of feeding exactly behind her.
No way.
In a chain. And then when they get to the end of the plankton strip that's being pushed in by the current, they'll then loop round and follow each other all the way back. You get cyclone feeding as well, where again the mantas sort of follow each other around and create this vortex almost, which concentrates the plankton and makes it easier for them to feed.
Are you serious?
So if they were each feeding individually, you wouldn't get that sort of effect and therefore making it easier to feed. So quite sophisticated.
Yeah, no joke.
And diverse feeding strategies. And then we also get them coming together on cleaning stations. So specific areas of reef where manta rays go to get cleaned, and there's this sort of symbiotic relationship with cleaner fish and cleaning species on the reef. And they tend to be quite specific reef areas. So we're talking like 10 foot by 10 foot area of reef, maybe a little bit bigger.
Wow.
That the manta rays always return to, like every morning or a couple of mornings a week. And it is also kind of a social area where you get a few of these manta rays coming together and sort of spending time on these reefs together. So although they are considered solitary, they do end up spending a fair bit of time together.
Maybe my spirit animal is a manta ray.
But then when they break off, if we look at our sightings, it's not like, oh, these two mantas turn up on the same reefs every day together, they're a family or anything like that. It's like they all have their random patterns, and then, yeah, like these 10 have this favorite cleaning station and they often turn up together kind of thing, but doesn't really follow, but then they all go off to other places. And
I gotcha.
Yeah, it doesn't make it easier for tracking them when they all have their own plans and they go off and do whatever they want.
Yeah, no, they're on their own time. It's like they go out during the day and they just party it up, and then they come home for family dinner, and it's kind of like, all right, everybody clean up and go get ready for bed.
Yeah, almost feels that way.
Now, so what do you mean by these cleaning stations? What is that?
So yeah, it's just a term that we use for any patch of coral reef that has a lot of cleaner fish living on it. It can also be cleaner shrimp for other species. And there's a lot of species on the reef that come and use these cleaning stations. So we get like sweet lips and groupers and fish like that. Turtles sometimes come and visit cleaning stations.
Oh, cool.
There's some cleaning stations out there that grey reef sharks use. So they come sort of hover over the cleaning station and get picked clean by parasites. And then obviously the ones that we're interested in are the kind of the manta cleaning stations, but all very similar. And the role of the cleaner fish or the cleaner shrimp in some cases in the ecosystem is to basically eat parasites and dead skin and detritus and stuff like that. So these animals visit the cleaning stations. They get rid of excess food kind of stuck in their teeth, like brushing your teeth, or If there's an injury or wound, they'll like pick away at the sort of dead skin and kind of clean up the wound a little bit.
Oh,
so it's
cool.
beneficial for the animal, and then obviously the cleaner fish or whatever gets food at the end of it. So it's this symbiotic relationship that's mutually beneficial to both parties.
Oh man, that really is like coming home for dinner and then brushing your teeth and getting ready for bed.
Yeah, and we do see quite often that after like big feeding events, we'll then see a lot more activity on cleaning stations. So potentially it's just a way for them to kind of spend a bit of time whilst they're digesting all this food that they've spent hours eating, and they kind of just hover around on this cleaning station, digesting the food before heading off looking for your next meal kind of thing.
God, that's awesome. I'd never heard of these cleaning stations before. And now we touched on some threats to manta rays, but like what are the big looming problems that mobulids are facing right now?
Yeah, so targeted fisheries, well, fisheries in general are probably the biggest current threat to manta rays. So targeted fisheries is when a fisherman or a fishing fleet or a fishing woman wants to specifically go out and hunt for and kill manta rays, so they're specifically targeting them. That's on the decline. There's less and less places that A, that's allowed, and B, kind of just happens.
Good, love to hear that.
And then there's bycatch fisheries, which is when a fishing fleet is going out in search of something else. So a lot of the time it's tuna, and their primary catch is tuna, but they're using these big gill nets or drift nets that they lay out in the water, and mantas and devil rays get entangled up in them, accidentally caught, but they're brought back on board, and in many cases either discarded at sea or landed in port and then, used for whatever purpose. Either the meat is consumed or the gills, plates are sort of dried off and sent out. So that's kind of now the big worry is how big is this issue of bycatch? Because mobular catch on the high seas in international fishing fleets is very poorly recorded. So there's very little data on it. It's one thing that we're sort of pushing these regional fisheries management organizations, RFMOs, to have better data collection to start with, just so we can get some baseline idea of how many of these mobular species are being caught.
Yeah, absolutely.
Is it seasonal? Are there specific times that we need to be worried about? How big are these animals? Are we catching pregnant females? Like, is there a specific area? All this sort of stuff that, like I was saying, it's impossible to find out going out looking for these individuals. But if we can utilize the fisheries data, which should be recorded anyway, that will hopefully answer a lot of questions, and then we can hopefully work to find ways to avoid these interactions. Maybe the fishermen can't be visiting certain areas and they're protected, or closed seasons, so that we can avoid these interactions between mantas or devil rays and fishing fleets.
Mm-hmm.
Then other threats, I mean, to a much lesser extent, unsustainable tourism.
Oh.
These feeding places and cleaning stations, they're known sites. They're quite easy to find. They're in shallow reefs and stuff like that. The mantas return. So it's quite easy to kind of exploit them as a tourism opportunity, which, if done responsibly, not really much of a problem. But if people are kind of touching the mantas or trying to ride them or chasing them or splashing, making lots of noise and scaring them off, those mantas are then not feeding or they're not cleaning. And what knock-on effect does that have, especially if we start doing this day in, day out for an entire season?
Right, that could have some really big consequences for just the population or even that area and them wanting to come back. And then, yeah, like you said, I mean, it's probably just a bunch of tourists who are on vacation for maybe a week, and they go out just one day. It's their one day to do this, and they're like, okay, I'm going to get the most out of it. I'm going to touch a manta ray or something like that. But then if everybody's got that mindset, then they're doing that 365. It doesn't matter who's doing it. It just matters if anyone's doing it at all. I mean, the manta doesn't care who it is. It's all the same person to them trying to get in their way and mess up their rhythm and their natural habitat.
Exactly. Like, I just want to get this one photo for Instagram, and like I'm going to get a bit too close to the manta, and it's fine. It's just for this one photo kind of thing. But as soon as everyone starts thinking that,
Right. It becomes a big problem then.
And then another big issue is a big unknown, I guess, is climate change and how that's going to impact mantas in the long run.
I bet.
There's potential impacts on these cleaning stations because it's coral reef systems that the fish rely on, and we're seeing coral bleaching, and how's that going to have knock-on effects? We're not entirely sure at the moment. And it's also going to change weather patterns and movements of plankton and productivity in some areas are going to become less productive in terms of plankton, zooplankton. So then that's affecting the food source of these animals. Whether that's just going to shift and change location and change sort of seasonality and it's kind of going to even out and be okay, maybe, or maybe there's going to be a reduction in general and there's going to be less plankton. That's another kind of possibility. So still too early to say, but that's definitely a big worry in the coming sort of 5, 10, 20 years time. What's the long-term impacts of climate change going to be?
And have there been any immediate responses noticed by these climate change effects? Like, I'm just thinking of the Great Barrier Reef and how in the last 10 years or so, there's been a number of coral bleaching events. So have there already been knockdown effects on manta populations or feeding or something from those bleaching events?
Not that I'm aware of off the top of my head, no. There might be that I just don't know about. I know we're kind of starting to look into it in the Maldives and trying to, unfortunately, backdate it because it's not really something that we thought of before. So there weren't health checks of coral reefs and stuff, and then of the specific cleaning stations, and then look at changes over time. And are we seeing less mantas coming from it and stuff like that? We have the kind of the general seasonal trends of how many mantas are seen and how many feeding and stuff like that. And in the Maldives, which is the data set that I know best, kind of the population is pretty healthy. There's no impacts of fisheries, or very, very minimal.
Oh, that's great.
Tourism starting to become a bit of an issue. But we haven't, it's still too early to sort of note anything to clearly attribute to climate change.
I gotcha.
Again, there's all these variables. So it's like, well, could it be climate change, or next year it's a much better season? And then it's hard to be definitive.
Exactly, yeah. It's just hard to be definitive about these kind of things, especially with such an unpredictable animal. And so one thing that I've always wondered is that, okay, so I've lived at least in a coastal state all my life, if not on the coast. And for me, I've never really known how to get involved in, I guess, helping shark populations in general, I guess, but also more specifically for mantas. I've never seen a billboard saying this is how you help mantas. Step 1, step 2, step 3, boom, mantas are saved. But I've always wondered, especially for the average Joe in Kansas, let's say, that's just completely far away from anywhere a manta would want to be. How can anyone get involved to try to help these majestic and beautiful animals?
Yeah, I mean, there's a few direct things you can do. I mean, there are volunteer opportunities and stuff like that. So if you're super engaged and super interested, there are charity organizations that accept volunteers and stuff, which is great. Even if you're just going on holiday to a dive destination and you see mantas or devil rays, you can submit those sightings to research groups. So the Manta Trust, we've got an ID the Manta page of our website where you can submit a sighting. Ideally, it's going to be a photo ID, so the spots on the underside of the belly, and then we can ID those individuals and we know who that is, and then we can say, okay, that's the same individual that's come back every year or whatever.
No way. I love that.
But even if it's just a sighting, a record of it, that it happened at that place at that time, and we have photo evidence kind of thing, it does build up on this sort of network of information of seasonality and trends. So if you're on holiday anywhere diving with mantas, take photos and submit it as citizen science. It's always helpful.
Citizen science is an amazing thing, and it's literally what the name suggests. It's science conducted essentially by regular old people like you and me. So it's these projects that researchers have put together, and then they create programs for everyday people to help out with. And so there are a number of different ways that people can help out, and a lot of them include just taking pictures of what they see, often in a park where people are going to be anyway. Or for the marine world, people take pictures underwater anyway, and so if they take pictures of sharks or manta rays and they get the right angle, then they can ID the fish and they're able to tell who's been where. And it's really helpful, and all you have to do is just Google search citizen science projects near me. Or if you're going on a hike one day, go to that park's website and just see if there are any citizen science projects that you can participate in. Sometimes it's just taking pictures of plants or squirrels or something like that. And same thing for diving or snorkeling. Just go to a dive shop's website or Google search citizen science projects in Sydney, Australia. And what's so amazing about citizen science is it helps scientists conduct their research for a really low cost. And a lot of times that means less money out of your pocket. And you get exercise. You get to go outside and see the beautiful world around us. And who doesn't love that?
Just kind of like learning and sharing knowledge about these animals. They're such interesting and fascinating and beautiful animals, and kind of spreading that awareness is important. There's always the sort of financial side of things. We're a charity organization. We rely on donations. So consider sort of making a monetary donation. You can adopt a manta ray. We've got sort of fun things like that on our website.
That's so fun. I would love to adopt a manta.
Yeah, it's always a really nice little gift for someone as well. And also just living a more sustainable life, reducing kind of seafood consumption or avoiding certain species, especially like tuna if it's caught in certain types of fishing gear like gill nets or long lines and things like that. Being a bit more aware of what you're eating and consuming can have a big impact. And then similarly in kind of just general lifestyle choices, reducing carbon emissions, trying to be a bit more green, don't use single-use plastic, all these sorts of things. That doesn't have a direct impact, so to say, on manta ray populations, but it all just leads to a sort of healthier environment and healthier natural ecosystem, which the manta rays need as well.
And if someone needs to feel like they get something out of it, then saving the environment helps them too. So that's one way to get something intrinsically out of it. But I would imagine that if someone's concerned about saving mobulids, then they're also concerned about the environment. I may be wrong, but that's just a hunch.
Exactly. I don't think anyone's going to stop using plastic bags just to save manta rays, but I mean, stop using plastic bags to protect all animals. Yeah, why not?
Oh yeah, I'm for that. I am all for that. And now we already talked about how we can help and get involved, but are there ways that we can be more hands-on, maybe like those volunteer opportunities that you mentioned with the Manta Trust?
Yeah, so specifically with the Maldivian Manta Ray Project, which, like I said, was kind of our founding project, we do accept volunteers during the summer, so June to November, 3-month stints. They are only for sort of qualified marine. You need a degree in marine biology and a little bit of experience and stuff because they're such competitive positions. But
Oh, wow.
A number of our affiliate projects around the world also take volunteers. No harm in reaching out because we never know kind of what projects are needing help or when they've got a new project that they need an extra staff member for or anything like that happening.
Mm-hmm.
And it doesn't always have to be marine biology as well. Like, we have a lot of people who reach out and they're an artist or something. I've currently got someone who's helping me put together a infographic about one of a paper that we're publishing at the moment, and they're just doing the drawings for it. So it's kind of...
Oh, that is so cool.
Yeah.
They're just utilizing their talents.
Exactly. Whatever you're good at, whether it's finances or fundraising or communications or website building, or there might be one of these skills that you've got that Manta Trust or any other organization doing conservation or anything else might lack and might want to take advantage of and utilize your skills. So yeah, see what you can offer as well.
I'm such a fan of that. I mean, when I think of the Manta Trust, I think, oh, okay, so I need a marine biology degree to help out with that. But no, you can use your talents and what you have, like your skills, because so many things are transferable and are useful in different situations.
And that's kind of the odd thing about these small organizations like the Manta Trust. We rely so heavily on people's passion. So, like, for myself, I run media and communications side of the charity. I don't have a degree in media and communications. I got a degree in marine biology. So there's a lot of things that I don't know and I'm learning and stuff like that. So yeah, often these groups are they have their niche speciality and maybe don't have some skills that other people can bring to the table.
Oh, definitely. And what are some projects that the Manta Trust is working on currently?
Yeah, we've got a lot on the go at the moment. Lots of fisheries. Well, obviously with COVID, a lot of the field work and stuff had to be put on hold.
Yeah.
Some countries are still not quite back in the field 100%, so still not really back to collecting data. In Peru, I know the team over there, they're keen to get back to a project where they're doing post-release mortality of oceanic mantas caught in fisheries.
Whoa.
So the fishermen are catching the mantas and then, okay, if they release them back into the wild, they've been caught in a net for however many hours. Are they able to still survive or are they just going to die anyway? What's that kind of rate of survival after being caught and then released? which we just don't really know about. It might turn out that they all survive, and then that's great, because then we can really push for like, okay, you catch these mantas, that's unavoidable perhaps. Then we'll work to just releasing them as quick as possible and in the handling them as best as possible, and that gives them a really good chance of survival, in which case that's quite good. Other projects in the Maldives, we're looking into reproductive life history traits of manta rays. So we've got an in-water ultrasound.
What?
That we're doing scans of pregnant mantas, but they're obviously quite visibly pregnant with a 1.2 meter baby inside them.
Yes, they are.
But the interesting thing is scanning the not visibly pregnant females to see if we can start to pick up on whether they are pregnant, just not visibly.
Oh my gosh.
And then look at like maturity stage as well, and of females, and at what point do they become sexually mature, because it's still not really a very well understood area.
That's so crazy. Underwater ultrasounds? Okay, now riddle me this. How do you take an ultrasound of a manta ray?
Good question. So we've got a quite neat bit of gear. It's in-water ultrasound, so it's actually designed, I think, for scanning cows, for like vets in cattle farms, essentially.
Oh.
But it's been waterproofed and everything, and then we've got like a smartphone, and it sends the Wi-Fi to that, so you can see I think it's sonogram. And it's contactless as well, so you have to get pretty close to the manta, but you don't actually have to touch the back. So yeah, we free dive or scuba dive, whichever is more appropriate, and you just kind of pass the scan over, and it records onto the iPhone or whatever.
That's nuts.
We then don't have the capabilities to kind of analyze that. That needs like a veterinary professional. So we then send those off to collaborating with the University of Cambridge in the UK, and they will analyze it and pull out like what the sort of different bits of the scan are, or like, oh, that relates to whatever anatomical section that they're looking at the moment.
Oh my god. What blows me away the most, other than being able to take an ultrasound of a 20+ foot manta ray, is how it's not invasive, how it's contactless.
Yeah, there's been some other studies on it using much bigger bits of equipment in aquariums, and there's videos on YouTube. You can go look at them.
Did I do this? You bet your buttery biscuits I did. The one I found was actually of Bindi Irwin doing an ultrasound on a spiny dogfish shark. And I'll post a link in the show notes so you can watch it too, and it's really cool because it shows all the steps that they went through and how they did it and how it works. So it's awesome. You should go check it out. Link in the show notes.
Takes kind of like 2 or 3 people riding on the manta to slow the manta down enough for somebody to like be scanning them, and it's because it's just this big clunky piece of equipment. So it's just not practical. It's not a good idea. So yeah, this new bit of technology, we don't need to touch them, just need to get pretty close to them, do a couple of scans, and then we can get some really great data, and it's completely non-stressful for the animals, which is great.
Man, what an improvement on technology. I mean, to have a team of people riding on a manta to stop them so you can take an ultrasound all the way to something that's contactless and you just scan, that's incredible. And I figured this, but it sounds like the Manta Trust is doing some really, really amazing and innovative science to give the world even just a basic understanding of how these animals function and live.
Yeah, I mean, there's lots of other stuff, like lots of our projects. Fiji is doing some tagging studies. We've got education programs. We've got fisheries work in Indonesia. All sorts of stuff going on all around the world.
Oh my god, that's so much.
Best to sort of follow our social medias and our newsletter for what's going on when.
Yeah, absolutely. And I'll make sure to put the Manta Trust social media pages in the show notes and also put them in the outro. And so I've got a couple more questions for you, and they're not so much related to the Manta Trust. They're more directed for you, Simon. So batter up. The world around us may seem to be imploding and exploding at the exact same time, but something's got to keep you going. Something is keeping you here and working for the Manta Trust. And so what is it? What is it that drives you, that keeps you motivated, and that helps you push through all the hellfire raining down towards you? And the rest of us, of course, too. It's not just you, I promise.
I think there's a lot to still hold on to. There's a lot of amazing stuff going on in the ocean that is still, I wouldn't say thriving, but still alive, and it's still worth protecting. So not all hope is gone. I feel like I just can't not do it. It's kind of my duty that I need to be doing my part for it. In terms of what excites me, I think the oceans are becoming more at the forefront of people's considerations, especially when it comes to the environment and that sort of stuff. It maybe used to be the rainforest and save the rainforest and like don't print too much paper and things like that. Whereas I think there has been a shift and people are becoming much more concerned about the oceans, which have maybe been somewhat neglected in the recent past. So I think that's really positive that we've got this shift. And here in the UK, David Attenborough's sort of Blue Planet and Blue Planet 2 and all these sorts of blue chip documentaries about the oceans and kind of bringing that life to people's screens and showing them the amazing stuff that's happening there, but also the threats to it, I think is hugely important.
When we work together, there is no limit to what we can accomplish. Today, we are experiencing environmental change as never before. And the need to take action has never been more urgent.
So I feel like we're starting to have a shift where people are becoming more aware, more concerned about the ocean. And I think that is a hugely important thing to get the vast majority of the general public on board with protecting this, because then that can help put pressure on government organizations and big multinational companies and things like that, which is so desperately needed.
100%. I agree. And I'm not trying to diss the rainforest or anything, because we obviously need that too, but it seems like we need a shift to recognize that the ocean is there too, and it's really important to our well-being and the health of our planet.
Yeah, I think the oceans is often like out of sight, out of mind, where people don't see what's going on, so they don't really care or aren't really connected.
Right.
Whereas that's starting to change, and like maybe they still can't see it for themselves, but at least people are bringing it to their attention and sort of talking about it, which, yeah, I mean, that's part of what the Manta Trust tries to do as well. We try to get people in the water with these animals and show them face to face. A lot of our education programs around the world with rural communities and stuff like that is to get the kids in the water snorkeling and to show them face to face like what the important stuff is.
I think that's so important that organizations and charities like the Manta Trust try to expose different communities, especially marginalized communities, to the underwater world that they might not get the chance to see otherwise.
Yeah.
And also with documentaries like Blue Planet. Those are fantastic because people that do live in the middle of the continent or have no relation or connection to the ocean can receive some sort of exposure. However minimal, it's still some exposure. And it can be really inspirational regardless of your current connectivity to the ocean and marine life.
Yeah.
Now, so do you have any personal future goals within the world of marine science?
Yeah, I'm hoping to do a PhD on manta rays, on the oceanic manta rays in the Maldives, which is a project that I've been managing for the last few years.
Oh, cool.
So again, sort of quite new population that we didn't really know too much about. Most of the Maldives, we see reef manta rays everywhere, but we get this one island where we get oceanics coming. So lots of really interesting stuff. That's also the species that is being fished quite heavily over in Sri Lanka. So for me, it's kind of like, is there a connection going on here? Are these mantas moving into areas where they're being fished? Maybe look at sort of genetic studies. Can we see if they're connected or stable isotope, or see what the sort of connection is between the fisheries and this population that we've recently discovered in the south of the Maldives. So yeah, lots of cool stuff there that I'm quite passionate about, and probably enough to turn into a PhD, but it will be a few years down the line.
Yeah, PhDs are a big commitment. But, I mean, I would imagine that there's plenty of data to work with, especially in the Maldives, because the Manta Trust was founded in the Maldives. So there's probably been plenty of projects that have come through and produced a lot of data. At least that's what I would assume.
Yeah, although this specific site is quite remote, it's quite far south, and the season for the oceanics is really short. So this year we had 50 mantas, but it was only over a 10-day period. So
what?
They rock up in a wave of mantas and then they're gone. And it's like, okay, well,
10 days.
Can't collect any more data until next year. So,
oh my God, that's so short. Just a nice quick 10-day sampling trip where you never sleep because you'll have to wait 355 days for them to come back around again.
Yeah. Well, so 2019 we had, I think, 330 mantas or something, but it was over a 4-week period, so it was a much longer season.
Wow.
But then it's like, okay, well, why was that season so much longer? Why were there so many more? Why, like,
Right.
all those sorts of questions that we just I'm not even starting to answer, really. Like, we barely know anything.
Oh, what do you know? That's great. It sounds like there's plenty of questions for a PhD student.
No, exactly. Lots of really exciting stuff, and super interesting.
No, but really, good luck with that. That's awesome.
Thank you.
It really does sound like there's still a lot that we can learn from these species.
Yeah.
And I know how daunting it is to think about all the different questions that you can ask, but at the same time, it's rejuvenating because there's so many different possibilities and there's so much to learn. That's what really gets me excited and really energetic about this.
No, for sure. Yeah.
All right. I don't really know why I'm going to ask you this question because I feel like it's kind of obvious. But what's your favorite animal?
Marine animal, probably oceanic manta rays are up there. They're so cool.
Yeah, I figured.
But so many different animals in the ocean like fascinate me. I absolutely love cuttlefish.
This throws me back to my senior research project about cuttlefish sex, which was titled, no kidding, Sex Cuttles, How Cuttlefish Do the Dirty. Yep, that was my college senior project. I loved every second of it.
I think they're so bizarre, but so cool.
Oh, me too.
Yeah. All the cephalopods, like octopus and stuff like that, they blow my mind.
They're fascinating.
Stuff going, sperm whales as well, I think are fascinating.
Oh, interesting. Have you ever gotten to dive or snorkel with any of these animals?
Cuttlefish and octopus, yes. Sperm whales, no. I've seen humpback whales in the water, but not sperm whales. But
that's too
people
cool.
I've spoken to who've been in the water near them say that it's insane because they're clicking and they're
oh, really?
sort of like feeling you out is so loud underwater when they're close to you. So it's,
God, I bet that just rings in your ears. But a beautiful ringing, of course. Because, whales.
Yeah, it's kind of a top of the list, or very close to the top is sperm whales, I think.
Hey, someday soon. I'll keep my fingers crossed for you, don't worry. And now this next question requires a little bit of self-assessment. And it's okay, don't hold back. But if you could be any animal that best describes your personality, what do you think it would be?
I don't know. I think if I could be any animal I wanted to be, I think I'd probably go for a penguin or something like that.
Oh, that'd be fun. I would love that.
Because then you get to spend a bit of time on land, which is quite fun, but then you're also incredibly agile in the water.
Mm-hmm.
Yeah, it looks like a lot of fun being a penguin, especially underwater. And then life on land is just kind of standing around and lying down and sliding around on ice, which can't be that bad either.
Lying around, that's my favorite thing to do as a human, so... And I would love to be able to slide like that on my belly.
Yeah.
Your world is a slip and slide.
Yeah, and then slip into the water and suddenly you're super agile and super speedy. That would be quite fun.
Oh yeah, and the thing that I would probably benefit most from is that they can withstand cold temperatures. I'm not at all like that, so if I had one superpower, it would probably be to be okay with the cold.
Yeah, it's definitely something I don't have.
That was the knowledgeable and passionate media and communications coordinator for the Manta Trust, Simon Hilbourne. You can find the Manta Trust online at mantatrust.org, and they're on Facebook, Twitter, and Instagram at Manta Trust if you want to follow them, and you definitely should because they've got great content. And on their website, there's also updates about projects that are being worked on, there are volunteer opportunities, and there's educational resources and activities for all ages. Even I like them, and I'm 24. They also have a newsletter that you can subscribe to stay up to date on all things Mobulas, and you can support their efforts through donating on their website as well. And of course, as we talked about, you can adopt a manta. This one-time donation helps fund this great organization, and you get some goodies that tell you about your new adopted flappy friend. They're super cute, so go check that out at mantatrust.org. You can find Simon on Instagram at s.hilbourne. That's s.hilbourne. And you can support this podcast by becoming a Patreon donor at patreon.com/elasmospod to keep this show swimming. Please rate and review this podcast and send that rating and review to me at elasmospod@gmail.com so that you can be entered into a drawing and share this podcast on social media to get 2 extra entries. You can find us on Instagram and Twitter at elasmospod, and on Facebook and YouTube at the Elasmos Podcast, A Shark's Universe. Don't forget to email your marine adventure stories to me at elasmospod@gmail.com. Oh, my voice cracked. It's alarming that's happening at my age. Our website is elasmospod.com, where you can find links to all these good things, and it was delightfully designed by Paul McNeely. Our super fantastic theme music was created and performed by Connor Blake and Wes McNeely. Wes can be found on Instagram at wes.mcneely1 and on YouTube at Wes McNeely. I can be found on Instagram at smcneely4335, and now that you've listened through the credits, here's my weekly update. So, my new job is basically just sampling seafood markets for some weight verifications on different fisheries. It's a whole thing, and I'll probably explain it one day, but the big idea is I'm basically just weighing different fish for this study that we're looking at. But anyways, so I'm in North Carolina, and blue crabs are a huge fishery. So we're sampling those, and guess what that means? I have to get over my fear of crabs. Yeah. And I'm going to blame my brothers, Wes and Paul, for this because when we were younger, on our beach vacations, we would usually go crab hunting at least one night while we were there. Totally normal, right? And crab hunting for us was just looking for those small ghost crabs on the beach, trying to catch them in a small fish net and then put them in a beach bucket to look at before we let it go and run off into the night. Well, how I remember these crab hunts going is that I, the youngest of everyone in my entire family, would hold the flashlight looking for the crabs, and also making sure I wouldn't step on them or the crabs wouldn't crawl over my feet, and then Wes or Paul would usually catch one. They'd pick it up, and then they'd chase me with it. They'd run after me with a crab in their hands. And this sibling torture has made it, how do I say this nicely, hard for me to handle crabs. So maybe I wasn't the best fit for this part of the job, and yesterday I went sampling for some blue crabs, and oh my gosh, if those aren't the biggest and strongest claws I've ever seen. After jumping a few times in front of the fishermen and getting some laughs, I finally started getting the hang of it. But the key advice that they gave me is to not be afraid. Good thing that's all I am, is afraid of the crabs and of getting pinched. So, as you can imagine, that was not easy. For some reason, that just did not click in my head. I wonder why. Thanks, Wes. Thanks, Paul. So it's a work in progress, but it was super fun, and I also saw wild horses yesterday on a barrier island.
How neat is that? That's pretty neat.
So thank you, North Carolina, because you're the coolest. Anyways, thanks again for listening, Elasmites. Y'all are the most amazing shark fanatics on the planet, and make sure to come back next week to listen to a leader in the great white shark community. That's right, it's huge, just like a great white. It's gonna be epic. I don't even know what that was. Alright, that's it for me. Get home safe, and I'll see you back here next week on the Elasmos Podcast. Later, skaters.